Welcome back. We have the trig functions defined, and now we just want a little bit of practice. So 2 examples in this video. This is the prompt for both of them. Let t be the real number corresponding to the point P, and again, t is the arc length. So in example, evaluate all trigonometric functions of t. Okay, so here we go. I need a little sketch. I always like sketches. I don't know why. They just help me visualize what is going on. So again, I'm going to draw the most perfect circle you've ever seen in your life. Yep, that's a perfect circle. And I'm going to label the point P on here. So roughly, let's say go over 3/5, maybe about there, and then up. So I'm like right there. We're going to call that P. And then T would be from 1, 0 over there. So that's T. Okay. And so with these, I want to find the trig ratios for sine of T, remembering the of T, cosine of t, tangent of t, and then those are the main 3, and then you can find their cofunctions, which would be cosecant of t for sine, secant of t for cosine, and then tangent cofunction would be cotangent. Okay, notice that on the reason I list all these is because on the left we don't have any prefixes. On the right side, we have all cosecant, cosine, cotangent. Okay, we'll see more about those later on. So I digress. Here we go. So sine is the ratio of, okay, this is x, this is y. Sine is y over 1. So this is just 4/5 divided by 1, or 4/5. Okay. Cosecant would be the reciprocal, so 1 over y. Again, I'm doing a lot of work. If you can get it in fewer steps, please, by all means, do fewer steps. Okay, but show your work. 5/4. Okay. We need to divide 1 by a fraction. The fraction flips. Cosine is x over 1. So 3/5 over 1, or 3/5. Secant 1 over x, so 1 over 3/5, which is 5/3. Tangent is the ratio of the y-coordinate to the x-coordinate in point P, so we get 4 over 5 divided by 3 over 5, okay? And this one might be the one that takes the most work, only because you have fraction divided by fraction, so let's see, multiply by 5/3, multiply by the reciprocal, right? So then, let's see, those are going to reduce, and then that'll reduce. I'm left with 4/3. Okay, cotangent, if you haven't picked up on the co-functions by now, you can just take the reciprocal of the other function. So 3/4. Okay, so really when we're finding all 6, find 3 of them. Well, find the main 3, and then take the reciprocal for the other ones. All right, point P. So I want you to pause this one, try it out. So again, in terms of steps, I recommend a diagram, sketch it out there, and then start with your trig functions, making sure to kind of establish sine, cosine, and tangent first. Get the cofunctions in there as well, and start forming the trig ratios. Okay, pause the video, resume it when you're ready to see the solution. And here's my solution so far. Okay, so notice I didn't box the answers for secant, cosecant yet, and I want to explain a little bit more about those. But notice I have a diagram drawn. Our point ends up being quadrant 4, so I'm just saying that t is going counterclockwise, right, from 1, 0 to that point. Coincidentally, if you were, for some reason, wanting to look at the going from 1, 0 to the point P clockwise, right, that would be negative arc length. Okay, you can do that too, but just make sure that you change all the t's to minus t's in your function. I digress. Okay, so then I formed the different trig ratios following the pattern of y over 1 is the ratio for sine of t. Cosine is x over 1. Tangent is y over x. Okay, most of them simplified nicely, or I could just do the math quickly. Secant and cosecant end up being a little wonky. Okay, for me personally, I am okay with this. However, some people find it really weird to divide by a fraction. So if you do that, let me I don't have enough room up here, so let me bring this down a little bit. So if I have 1 over square root of 2 over 2, right, I would multiply by 2 over square root 2, 2 over square root 2, and those would reduce, and I'm left with 2 over square root 2. Okay, again, perfectly valid answer. However, some people historically don't like square roots in the denominator, and you have to do something called multiplying by the, excuse me, I was going to say multiply by the reciprocal. It's not that. It's called rationalizing. And so what you want to do with the process of rationalization is multiply the denominator by whatever radical you need so that you get a nice perfect square, perfect cube under the radical. Okay, so you'd multiply by square root of 2 over 2 in this case, because then you'd get square root of 2 over 2 all over square root of 4 when you multiply underneath the radical. So you get 2 over square root 2 over 2, that would reduce, and you're left with square root 2. Okay, a little cleaner than what we had up here, but mathematically, I use equal signs throughout, so all the same. And similarly, you can go through similar steps and get negative square root of 2 for cosecant. Okay, again, either one is perfectly acceptable. All right, so this video just allowed us to get a little bit more practice with writing out the trig functions, working with them using arc length, and we'll see a little bit more work with trig functions coming up.